Hello everyone. In this video, we are going to see about neutrons. What are neutrons? Who discovered neutrons? What are the properties of neutrons? Now, before we do that, let us answer one question. What contributes to the mass of an atom? In Rutherford's atomic model, in the alpha ray scattering experiment, there we have seen that mass of an atom is concentrated in the nucleus. Now, electrons, they have very less mass. So if the mass is concentrated at the nucleus, then what is those entities that contribute the mass of the atom? That means whatever is present in the nucleus of an atom, that attributes to the mass of an atom. Scientists observed one more thing, that hydrogen has one proton, whereas helium has two protons. But its mass is about 4 times that of hydrogen. That means mass of helium containing 2 proton is almost 4 times that of hydrogen. If it is so that mass of the atom is due to the nucleus in it, and if it is so that the nucleus has only protons, then the mass of helium with respect to that of hydrogen should have been double, because helium has 2 proton and hydrogen has 1 proton. Since it is 4 times, that means there are some other entity inside the nucleus that contributes to the mass of the atom. This led to the discovery of another particle inside the nucleus, and it is known as neutrons. Let us see the discovery of neutron. Scientist James Chadwick in the year 1932 discovered neutron. And do you know who was James Chadwick? James Chadwick was a student of Ernest Rutherford, and he discovered neutrons. Now, what did he discover? He discovered neutron, which is chargeless, which doesn't have any charge, and its mass is nearly equal to that of proton. These are the two important findings. One is the neutrons doesn't have any charge, and the mass of neutron is almost equal to that of the mass of proton. Now, why was this discovery of neutron important? Why should we study about it separately? Because this study explains why the mass of an atom is greater than the total mass of the protons in the nucleus. That proves that if the mass of the atom is due to the nucleus in it, and if the nucleus has protons, but the mass of an atom is greater than total mass of the proton, that actually means some other particles are also present inside the nucleus, and these particles are chargeless and are known as neutrons, which has the mass almost equal to that of the proton. Now, this study also helped to explain the existence of isotopes. And what are isotopes? Isotopes of element, they have same number of protons but different number of neutrons. Isotopes of the elements have same number of protons but different number of neutrons. Like hydrogen. Hydrogen has isotopes like H11. Now remember, this you did not see before. When I write any element, I write something at the subscript. This shows number of protons, which is also known as the atomic number. This is also known as the atomic number. And something written as the superscript, this shows the number of proton plus the number of neutron, which is known as the mass number. Okay, this is known as the mass number. Remember that mass number has symbol A and atomic number has symbol Z. So what are the isotopes of hydrogen? This H11 with atomic number 1, number of proton 1, number of neutron also 1. number of proton 1, number of neutron equal to 0, that makes the mass number also equal to 1. This isotope of hydrogen is known as protium, and protium has number of proton is equal to 1, number of neutron equal to 0. The other isotope is deuterium. Deuterium is another isotope of hydrogen, and it has what? Its symbol is D, deuterium, but element has symbol H for hydrogen. Its atomic number is 1, mass number is 2. And what does it mean? It means it has proton equal to 1, same number of proton but different number of neutron. And what is that number of neutron? Number of neutron is equal to mass number minus atomic number, and it is 2 minus 1 equal to 1. So this is an isotope. Deuterium is an isotope of hydrogen, and these two, what are the relationship? Protium and deuterium are isotopes. The other one is tritium. Tritium is another isotope of hydrogen. It has number of proton equal to 1 and the mass number is equal to 3, which means number of proton is equal to 1 and number of neutron is equal to 2. So in all these cases, you can see that they have same number of proton but different number of neutrons. And what is the relationship between these three? They are the isotopes of hydrogen, right? So here it is. Now, this also opened the field of nuclear physics, leading to various developments, various studies in nuclear reactor, artificial radioactivity, nuclear fission, and nuclear medicine. Where are neutrons found? Just now we have seen that neutrons are found inside the nucleus. And let me add on one more concept, that is the number of protons and the number of neutrons inside the nucleus. It may be the mass number, just now I have said, but these entities are collectively known as nucleons. If I say nucleons, that means it shows the total number of protons and neutrons. Now, it doesn't mean that nucleons is the mass number. Rather, I can say mass number shows the number of nucleons present in the nucleus. Okay, so this is how you will explain it. Now, where are neutrons found? They are found in the nucleus of all atom, and except ordinary hydrogen. Now, what do I mean by ordinary hydrogen? Ordinary hydrogen means protium, which exists mostly in the nature. Okay. Now, relative charges of subatomic particles. Subatomic particles are electrons, protons, and neutrons. And the symbol of electron is E minus, proton is P plus, and neutron is N0, showing their relative charges. -1, +1, and 0 respectively. Now, this part is of discussion which you try to understand. What is it? Why are neutrons important in the nucleus? And I said, well, when I was actually starting the video, I said, why do we need to study about neutrons separately? As a separate video I gave. See, its importance is that it explains how the particles, how protons remain inside the nucleus and keep the nucleus stable. You know that protons are all positively charged. Now, inside the nucleus, if there are all protons, like charges should repel each other. We know like charges repel each other. Then how is it that the nucleus is stable when you have protons which are positively charged? Neutrons will not matter, you may think. But actually the number of neutron matters. Why Because they intervene these charges. In between the proton के बीच में अगर न्यूट्रॉन आ जाता है तो क्या करता है कि ये जो प्रोटॉन का आपस में रिपल्शन है, ये रिपल्शन इज रिड्यूस्ड. It reduces the repulsion between the protons, for which it gives extra stability to the nucleus. तो इसके लिए एक चीज तो ध्यान में रखना ही चाहिए, दैट नंबर ऑफ न्यूट्रॉन कैन बी इक्वल टू द नंबर ऑफ प्रोटॉन, फाइन, बट इफ इट इज ऑल्सो greater, then it also gives extra stability. Why, you know? Because for heavy elements में क्या होता है, heavy element का मतलब है कि उसका atomic number जो है Z, which is equal to number of proton, वो काफी ज्यादा है. अगर वो काफी ज्यादा है तो रिपल्शन इनसाइड द न्यूक्लियस भी तो काफी ज्यादा होना चाहिए. तो इसमें जब न्यूट्रॉन्स, हेवी एलिमेंट्स का क्या होता है कि नंबर ऑफ न्यूट्रॉन्स भी काफी ज्यादा है, एंड एट टाइम्स इट बिकम्स ऑलमोस्ट डबल. तो अगर न्यूट्रॉन्स ज्यादा है तो क्या करते हैं, ये रिपल्शन को रिड्यूस कर देता है, फॉर विच व्हाट हैपेंस, द न्यूक्लियस ऑफ द हेवी एलिमेंट बिकम्स स्टेबल. So let us see. Protons repel each other because they have positive charge. We know like charges repel each other. Neutrons का क्या काम तब हो जाता है? It reduces the repulsion between the protons and helps the nuclear force to be strong and keeps the nucleus stable. One more thing you see, heavier atoms need more neutrons for stability. That gives extra stability to the heavier atoms. So see you in the next video. So bye champs.